Welcome back, everyone, and welcome to Chapter 5. This is Unit 2B, Relationships in Triangles. First, in this video today, we will talk about perpendicular bisectors. A perpendicular bisector is a segment bisector that is also perpendicular to the segment. So, for example, this line here, L, is a perpendicular bisector of segment AB because it bisects segment AB as well as being perpendicular to segment AB. There's something special that we know about the perpendicular bisector. If a point is on the perpendicular bisector of a segment, then it must be equidistant from the endpoints of the segment. So for example, on this problem up here, if we had a point anywhere here on line L, whether it's above or below segment AB, these points must be the same distance from B as they are from A. And it would work for the other point above too. It has to be the same distance from A as it is to B. So for example, in this picture here, if segment CD or line CD is a perpendicular bisector of segment AB, it's perpendicular and it's bisecting it, meaning it's cutting it into two equal parts. Then CA, the distance from point C to point A, must be the same as the distance from point C to point B, the other endpoint of the segment. This also works in reverse. It's called converse of perpendicular bisector theorem. We switch the hypothesis and conclusion to say that if a point is equidistant from 2 points, then it must lie on the perpendicular bisector of the segment with those points as endpoints. So for example, since point E is the same distance from A as it is from B, I know that point E must lie on the segment bisector of segment AB, those 2 points that it's equidistant from. Just note that a perpendicular bisector, when you draw this for one side of a triangle, it does not have to go through the vertex, the opposite vertex of a triangle. So for example, on this, line L is a perpendicular bisector of this side, XY, but it does not go through the opposite vertex, point Z. It doesn't have to go through that opposite vertex. All right, let's do some practice problems. It says find AB. So that's the length from A to B. Now I see that segment BD is being bisected by line AC. It's being cut exactly in half, and also line AC is perpendicular to line BD. Therefore, point A is on the perpendicular bisector. Remember, any point on the perpendicular bisector is equidistant from the endpoints of the segment. So A has to be the same distance from D as it is from B. Therefore, AB has to be equal to 4.1. Let's do another. This time it says find WY. I see that point X is the same distance from W as it is from Z. Therefore, point X must lie on the perpendicular bisector of segment WZ. I already see that it's perpendicular. It also must be bisecting. So I see that YZ is 3 units. Therefore, WY must also be 3 units. Next, it says find RT. I see that point R is on the perpendicular bisector of segment QT. Therefore, point R is the same distance from the endpoints of the segment, Q and T. So I know that QR must be the same length as TR. So I can set up an equation. QR is 2x plus 3. TR is 4x minus 7. In order to solve this, I'll add 7 on both sides. And then subtract 2x on both sides. Finally, divide both sides by 2 to get x equals 5. However, this is not the final answer because they asked us to find RT. I know that RT is equal to 4x minus 7. So I can plug in 5 for x. So I have 4 times 5 minus 7. I'm just substituting in 5 for the value of x. Therefore, RT is equal to 13. Pause the video and try the practice problems below. Here are the correct answers for A and B. Here's the correct answer for C. I wrote out some extra explanations just so that you can understand them a little bit better. Make sure you know that you do not have to write all that out. All right, some more vocabulary. The word concurrent lines means when 3 or more lines intersect at the same point. The point that they intersect is called the point of concurrency. The point of concurrency for the perpendicular bisectors of a triangle is called the circumcenter. If we took triangle ABC and drew all the perpendicular bisectors for each side, so segment ZP, segment YP, and segment XP, all 3 perpendicular bisectors, one for each side, they will all meet at one point, point P. This point P is called the circumcenter. A fun fact is that the circumcenter is the center of the circle that circumscribes the triangle. That means that it goes through each vertex of the triangle. Goes around the triangle. The circumcenter lies in different spots depending on what type of triangle we're looking at. For an acute triangle, the circumcenter lies in the interior. For an obtuse triangle, the circumcenter lies in the exterior. For a right triangle, the circumcenter should lie directly on the hypotenuse. We also have a theorem called circumcenter theorem. It says that the circumcenter is equidistant from each vertex of the triangle. So that means that if this point P is the circumcenter, it's the same distance from each vertex of the triangle. The vertices of the triangle are the points where the angles are, A, B, and C. They're the vertices of the angles that make up the triangle. So AP has to be equal to BP, which has to be equal to CP. Imagine if P is the center of the triangle that goes around this circle, wouldn't each of these radii have to be equal? I want you to reflect on this question. I know it's not on your notes, but you can still write it at the bottom. Claudio says that from the information supplied in the diagram, he could conclude that point K is on the perpendicular bisector of segment LM. Caitlin disagrees. Is either of them correct? Please explain your reasoning in 1 to 2 complete sentences. That's all I have for you today. See you tomorrow.